Hi everyone, this is Anson, and I'll be talking about the first LO, which is to analyze system using free body diagram method. And as for our case, we have chosen twin tower as our structure, and we'll be only focusing about the sky bridge of the tower. First, let us get the dimension of the bridge right. So based on the information I got online, the legs of the sky bridge is approximately 42.6 meters. And then for the top part of the bridge, it's about 58.4 meters long. And lastly is the weight of the bridge, which is about 325,000 kilograms. Okay, let us construct our free body diagram on the right side. Here. So for the top part, let us divide 58.4 by 2. So we will be getting 29.2 meters on the left and on the right. This one is 42.6. And since it's a right angle triangle, we are able to get the vertical length of the triangle, which is 31.02 on the left and on the right. And also, since we have the three lengths of the triangle, we're able to get the angle over here and here. So over here it's about 46.73, and over here is 43.27, 43.27 and 46.73. Okay, now since the shape of the sky bridge is identical, so we will assume that the centroid is located in the middle of the bridge, and therefore the weight of the bridge will focus on that point. So after converting the 325,000 kilograms into Newton, we'll be getting 3188250 Newton. Whoa, that's a very heavy bridge. And then the force, since there is a force acting downwards, which is the weight of the bridge, there should be another force to cancel out the weight of the bridge. If not, the bridge would have collapsed. So that's why we have the two legs over there to support the weight. So the force that cancels out the weight is actually this one and this one. We do not know the magnitude of these two forces. Far East will help us figure out later. So let us name all the points. Let us name this A, B, C, D, and E. Since there is a joint in the middle here, so by using method of joint, we can draw a free body diagram for the joint. So which I already done here. Let us assume that all of the unknown forces, which is CA, CB, CE, CD, all these points are in tension away from the joint. So this CA is away from C, AC is away from A. So if we were to get a negative value, it simply means the opposite direction. So is that not necessarily be compression or tension? We do not know it yet. After we calculate on, we know it. So if it's negative, it will be the opposite direction like this. If one side is tension, the other side is definitely going to be tension. And one side is compression, the other side must be compression. So that's all for the free body diagram part of the structure. Next, Far East will explain about using free equilibrium method to find the value of the forces at point A and E, which cancel out the weight of the bridge. Thank you.